the EDM the system, and then we talk about this, the two different categories. One is this is RC, another one is a transistor type of pulse generator, and how they are different. I told you guys, okay? So by the way, guys, and for the remaining of our semester, we will have another modeling, another abacus, advanced IBM modeling, the homework. In addition to that, we will have a field trip to the Oliver Hall, okay, to see the CNC machining, and after that, I will talk about my research. So that's all. No homework. If you want to do more homework, let me know. I will. So no homework for the rest of the semester? Some students want to use homework, so if you want, just let me know. I don't want homework. I don't want it. Okay? You don't want it? We want. We'll want homework. Will wants it. Give it to him. I don't want it. Okay. I'm kidding. Okay. So we only have one advanced IBM homework and one field trip to Oliver Hall. All other time I will talk about the state of the art of the machining things. So servo control system. This is you must have the control. Okay, so the EDM usually the EDM, the electrode can be moving, or and the workpiece can be moving also. As long as you have this is the relative motion between the electrode tool and this workpiece, that will be okay. So in the EDM process, to ensure stable and efficient machining, the gap condition between the electrode and workpiece must be maintained as a desired state by servo-controlled electrode feeder mechanism. You must have this servo control system. A stable gap, okay, the gap between the electrode and this workpiece must be remained stable. Also enable better dimensional accuracy of the micro machine, the features. So during the EDM, the discharging gap between the two electrodes and workpiece is of several micron or even less. It's very, very small. And therefore, it requires design of a special servo control compared to conventional EDM. So this is a servo control system. The microcontroller is the most important module of a servo control system on which sends the digital signal, and translate analog to digital signal by AD module and drives the motor by the PWM. Are you guys familiar with microcontroller and PDM? Are you familiar with AD module? No? Measure, have you taken the measurement?
I'm in there right now.
You are taking right now. Okay.
We haven't done. We just started our project today.
Okay. Who is teaching?
Mark.
Okay, Mark William, right?
Yeah.
Okay. So the PDM. So in the mechatronics, that is the senior course. I'm going to teach you on PWM. I'll also talk about some microcontroller. So to every the micro feeding the shift, the detection result must be feedback and to the microcontroller to adjust the output shapes in order for the precise control of servo control system. So this is a servo control can be operated based on different algorithms or principles such as predicting the gap distance and offset tool positions. Ignition delay time, average is the gap voltage, and average delay time. So here is you should know this is the basic about this is the control. Now here this paragraph talks about ignition delay time, and so it is an important indicator of isolation condition of discharge gap, and larger gap width causes long ignition delays and resulting in a high average voltage. So you take a look at this paragraph by yourself. Okay? So here is a principle of servo control system based on this ignition delay. And so here is, you can see this is gap voltage. So this is gap voltage also. And this is a forward, this is a large gap, this is a proper gap. So here, see, this is a gap, okay? This is a larger gap, and this is a proper gap, and this is a small gap. And you small gap means retract the cable. So I'm not, and you can just take a look at this one. And then we talk about another component. So this is the dielectric circular system, or this is the flushing unit. And we know that after the electrode, the sparks, they will have some materials will be removed from the workpiece. So this debris needs to be flushed away. Okay, so this needs to be flushed away. So this is the electrical circulation. You must have a system. It's an integral part of the EDM. The dielectrical system consists of a dielectrical fluid. You need to put the fluid there in the container and also in the pump. And the dielectrical reservoir, okay? You must have the reservoir to contain the fluid, the pump to supply the dielectrical fluid into the work tank and filter, and to remove the debris particles from the dielectric, and to ensure the circulation of fresh dielectric to the machining zone. So filter is very, very important. The reason is that whenever you use dielectric to flush away the debris, okay, if some tiny particles will go with this is dielectric and go back to the tank, and you need to fill them out and throw them away, and otherwise it is not good for the system. So the flushing pressure, you must have pressure control valve and to maintain control the flushing pressure of the dielectric, and you should have some the pressure. And dielectrical fluid is the most important component of the flushing unit. It provides no electrical barrier between the electrode and workpiece, and acts as a means for removal of spark debris from the spark gap. And here are major functions of this system. I will ask you guys to tell me, okay? I will ask you guys to tell me, use your own language to tell me what are the functions of this dielectrical system, dielectrical fluid. So this is a system. So here, to distribute this dielectric flows through the spark gap. The spark gap means the EDM, electrode, and the workpiece, and to remove gases and solid debris generated during EDM because of high temperature, and to introduce the fresh and clear dielectric fluid into the machining region. That means the pump will bring will pressure. This is a fresh and clear dielectric fluid into the machining region. And third one is to flush away the chips, the debris, okay, or the metal particles generated in the spark gap, and to maintain the dielectrical temperature well below its flash point. So the temperature, because the water, this is dielectric fluid, the temperature will be increasing. Why? Because if you keep using this EDM to machine the workpiece, the temperature and definitely the heat will transfer to the dielectrical fluid. As a result, dielectrical fluid will have higher temperature. So now you need to maintain the temperature, just lower the temperature. So to act as a cooler for cooling the electrode and the workpiece. So this is very, very important. Okay. Any questions regarding this dielectrical circular system? Sometimes the cooling rate plays a very, very important role for the EDM. And for the EDM, now some people are using this is the vibration assisted EDM. If you don't mind, you can just write down the vibration assisted EDM. And what is what is the benefit of vibration assisted EDM? Right? The tank, the reservoir is vibrating. If it is vibrating, and the cooling rate of the dielectric fluid will be changing. Right? But this is one of my research area. I want to see under what condition and what vibration frequency and amplitude I can get a desired cooling rate. And this cooling rate, if I can control the cooling rate, I can control the microstarter, result in the microstarter of the workpiece outside EDM. You know the cooling rate plays a very important role in the microstarter, right? Do you know that? You are taking the material science, are you? No? Okay. Maybe next year. Material science, the same material. If you elevate the same material onto the same temperature, and then you cool it using different cooling rate, and you will get a different microstarter. So here, we talk about this is the analysis of pulse. We just say pulse. The EDM have a lot of pulse. Pulse is used in the EDM process. But depending on the situation in the gap, which separates electrode and workpiece in the EDM, and principally 4 different electrical pulses may be distinguished. Okay, so this is the pulses. Open circuit or open voltage. This is effective discharge or real spark, arcs, and short circuit.